Again, nodal analysis, I just finished saying that nodal analysis is a technique we use when you have a lot of nodes, not just a single node. It is based on KCL, Kirchhoff current law. We do KCL at each node. That's really what we're doing. It's based on KCL. And we always do KCL at each node except the ground one. We always pick one node to be the ground, and we neglect that one because if you add it, that's just repeating. You're just wasting your time. So if you take this example, this is 3.1 amp. Can you see that on the screen? Is it clear? 2 going through 5 here. 5 ohms and 1 ohm. And there's another current source right here. And the value of that current source is negative 1.4 amps. You can leave it the way it is. If you don't like it, you can change the direction, making it going up with the value of what? Plus 1.4, yes. So the ground is my bottom node. This is my ground, so I'm going to neglect that. I'm not going to do KCL at that node. That's my ground. I have 2 nodes. There's one node, we'll call it N1, and this is node 2, N2. N1 is really all of this, because the wire doesn't change anything. That's N1. And N2 is all of this. That's what N2. There are no other elements, just a wire connecting them. We said nodal analysis is really KCL at each node. Now, I got to define currents going in. So I'm going to define the current in any direction I want to. So there's 2 nodes. I'm going to label the voltages at each node. So maybe I should draw the circuit one more time. 3.1 amp. Because I already put a lot of stuff on it. I don't have to graph it, but because I wrote so much, well, not so much, but a few things on it. And I like to change this to positive. I never liked those negative values. Who cares? So I'll make it 1.4 amp. Do we know what the voltage here is? No. Nobody knows. That's node 1. The voltage is unknown. Nobody knows that. So I'm going to call this voltage V1. Does anyone know what the voltage here? No. That voltage at node 2 is called V2. Now I just finished saying nodal analysis is really a KCL at each node. Current going in equals the current leaving. Well, I don't know where the current, what's happening here through these. I know this is going in. I know that's going in. What about this one, and that one? Does anyone know which way? No, and we don't care. You assign current any direction that you want. So through the 5 ohm, which way you want it to go, left or right? You choose.
Right.
Right? Okay. I'm going to call this I5. How about this one, up or down? Down. I2. I'm going to make this going up intentionally just to be different. I1. I just make an assumption, any direction I want. I go, let's assume it's going that way. And just do the math. So here we go. KCL at node 1. The top node, this one. Let's look at the current. What is the current going to that node? Remember, KCL says if you take all the current going into the node should equal all the current leaving that node.
3.1A.
3.1 going to it. And what's leaving? I2 plus I sub 5. Good. How many unknowns in that equation? Two. One equation, two unknowns, not good. Okay, let's try the other one. Maybe the other one will help us. KCL at node 2. Again, the current going in equals the current coming out. What is going to that node? I see 1.4 right there. What else going to it?
I sub 5.
I sub 5, and what's leaving?
Nothing.
I sub 1. Oh, no, I sub 1 is going in, I define it. So plus I sub 1, I forgot, I define it going in, equals what? What's leaving? Nothing. There's my other equation. Now, how many equations by how many unknowns we have? Two equations by 3 unknowns. I'm in trouble. So somehow I need to rewrite I sub 1, I sub 2, I sub 5, maybe in terms of V1 and V2, because there's only 2 unknowns there. Let's look at I sub 2. The current is going this way. So the voltage, the way I drew them, the voltage, this voltage minus that voltage. What's this voltage on the top? V1 minus, what's the voltage on the bottom? 0 divided by 2. Ohm's law I'm using. Ohm's law says V equals I times R, which means I equals V over R. So that's what I did here. I'm taking the voltage across that. Let's look at I sub 5. Right here, it's going to the right. So it's which voltage? V1 minus V2 divided by what? 5, yes. And let's look at I sub 1. It's going up there, so which voltage? 0 minus what? What's the voltage on the top? V2 divided by 1, which is what? Negative V2. Now, if I take these two equations and replace I2, I5, and I sub 1 with these values, I will have how many equations by how many unknowns? 2 equations by 2 unknowns. Here we go. 3.1 equals I sub 2. What is I sub 2? V1 over 2 plus I sub 5, which is what? V1 minus V2 divided by 5. My LCD is what here? 10? So let's multiply each one of these by 10.
Why is it 10?
2 and 5.
Oh.
31 equals what? 5 V1 plus 2 times V1 minus V2. Clean it. 31 equals what? 7 V1 minus 2 V2. Let's take the second equation. 1.4 plus I sub 5. I sub 5 is V1 minus V2 over 5 plus I sub 1, which is what? Negative V2 is equal to 0. What's my LCD here? 5. Is that a 7 here? If you move everything to the right side, you'll have 7 equals what? Negative V1 plus what? 6 V2. Here's my two equations by two unknowns. Now let's solve them. Now the circuits is over. Now bring in the math. Here's my first equation. And here's my second equation. I can multiply this equation by 7 and use the elimination method. Leave the first one alone. Multiply by 7, that's a 49. Negative 7 V1, 6 times 7, 42 V2. When you add the two of them, gone. 9 and 1, 10, 0, carry 1, that's an 8. 80 equals what? 40 V2. What's V2 equal to? 2. So now I can use either equation to find V1. 31 equals 7 V1 minus 2 times V2. What's 2 times 2? 4. Bring this one here. 35 equals 7 V1. V1 equals what? 5. If I know V1, V2, can I find I sub 1, I sub 2, I sub 5, whatever I'm looking for? I sub 2 is going to be V1 divided by 2. What's V1? 5? 5 over 2 amps. I sub 5 equals V1 minus V2 over 5. That's 5 minus 2 over 5. Is that 3 over 5, which is what? 0.6 amp? And I sub 1, it says you were wrong because I made the assumption it's going up. They tell me no, it's negative. Negative V2. V2 is 2, negative 2 amp. It says you're wrong, it's going to be 2 amps coming down. Not going up, coming down. And that's how you solve them using nodal analysis. We just write a KCL at each node. And what happens when you do KCL, you're always going to have more unknowns than the number of equations. So you have to rewrite each one in terms of the voltage to shrink it down. Let's try another one. And we can still use like simplifying. If you see resistors in parallel, combine them. Resistors in series, combine them. Make the math easier. Let's take this problem. This is 2 amp. 7 ohm, 7, and 3 ohm. $15, 5, and this is 4 amps. And the question probably find I, the current going in. We'll call it I here. Find I. Now, me personally, the first thing I would have done is what?
Combine the,
Combine these two resistors. Why am I having two here? Now, can I take these two sources, add them together, make it one source? No. They're not in parallel. You get that resistor between them. If I didn't have that resistor here, yes, I can, because they'll be in parallel. So again, I have two nodes. That's V1. That's V2. Node 1, node 2. Voltage 1, voltage 2. I don't know the voltages there. The ground doesn't count, the bottom one. So I'm going to have, at the end, I'm going to have two equations by two unknowns. And this is I. I'll call this IX. Call this IY. Notice I'm not even thinking. I don't want to think about which direction they're going to be going. KCL at node 1. That's this node. What is going to that node? 2. What's leaving that node? I sub x plus I. KCL at node 2. That's that node. Bless you. What's going to that node? 4 plus I, and what's leaving that node? I sub y. So notice I have, there's two equations by, again, three unknowns. Can't be done mathematically. I need to take these equations and rewrite them. Rewrite them in terms of what? V1 and V2. So here we go, I sub x. I made it pointing down. So it's this voltage on the top, which is V1, minus what's on the bottom, which is 0 divided by 10. I is defined going in that direction. So it's V1 minus V2 divided by 15. I sub y, it's defined coming down. So it's this voltage minus this voltage. V2 minus 0 divided by 5, which is what? V2 over 5. So what do we do now? We're going to go back to these two equations, rewrite them, but in place of I sub x, I'm going to put that. In place of I, I'm going to put that. So 2 equals I sub x, which is V1 over 10, plus I, which is V1 minus V2 over 15. My LCD for 10 and 15 is 30. You multiply by 30, you lose your fractions. You'll have 60, 3V1 plus 2V1 minus 2V2. Clean it. 60 equals what? 5V1 minus 2V2. Let's take the other equation. 4 plus I. I is what? V1 minus V2 over what? 15? Equals I sub y, which is V2 over 15. Over 5, not 15. What's my LCD? 15. 60 equals, 60 plus, not equals, I didn't get to the equals yet. V1 minus V2 equals what? 3V2? 60 equals negative V1, is it plus 4V2? There's my two equations by two unknowns, right here. Now I just gotta write them and do the math. $60 equals 5V1 minus 2V2. 60 equals negative V1 plus 4V2. Multiply this equation by 5, you'll be good. You'll cancel V1. $60 equals 5V1 minus 2V2. 300 equals negative 5V1 plus what? 20V2. 360 equals 18V2. V2 is going to be, what's 360 by 18? Is that 20? I found V2. Can we find V1? Any one of those equations, doesn't matter. 60 equals 5V1 minus 2 times 20, which is what? 40. 60 minus 60 plus 40, when you bring it to this side, it's 100 equals 5V1. What's V1 equal to? 20. I don't like the camera today. It's kind of rich. Once I have all the values there, can I find I sub 1, I sub 2, or I sub x, I, and I sub y? I sub x was V1 over 10. What's V1? 20. 20 over 10? 2 amp. They weren't looking for it. They just wanted I. I equals V1 minus V2 over 15. Well, V1 is 20, V2 is 20. 20 minus 20, 0 divided by 15, which is 0 amp. There's no current going through that resistor. And what is I sub y if you need it? My equation says V2 divided by 5. V2 is 20, 20 divided by 5, which is what? 4 amps. So we got I sub x, I, and I sub y. I'm looking at a picture in our book. When you look at it, it looks really ugly. But let's see. Time-wise, we're doing good.
I have a question. So if you go back to like looking at that circuit, so basically that 15 ohm resistor is doing nothing?
There's no current going through it, yep. Because the voltages happen to be the same here. There's no power absorbed by
Did you
it.
make those numbers up, or is that?
I just took a problem out of the book, but the way they set it up there just happens to, the voltage here happens to be 20, the voltage here 20, which means there's no power absorbed by that one, there's no current going through it. There's no voltage drop there. It's like having a wire there. Except if there's a wire, there'll be a lot of current going through it. Current takes least resistive path. What about if you have this problem? Again, it looks ugly. -8 amp. Leave a space on the top. It's going to be something on the top. There's the 1. One, 7, -25, -10. Here's what they have here. They have a source here of -3. Then they have a resistor here. Jump over this and connect it right here. The value of that is 4. The question determined the nodal voltages. So there's one node, V1, V2, and V3. What are they? So they're looking for, this is V1, this is V2, and this is V3. What are these voltages? And when you look at that, it does look a little bit scary there. So what I'm going to do, just fix it quickly and show you just a little drawing there. Leave a space on the top. So I'm going to change the direction of the current to 8 amps coming down. There's really nothing wrong with negative numbers. I just change them to positive. I'm going to make this going up there 25 now. And let me come back and look at that -3. That's right here. I'm going to change the direction of it. Make it 3 go in that direction, between this end and that end. And where's that 4 ohm attach? Between this end and what end? That one. So I can go with that and make it like this. I like that circuit better instead of jumping over and crossing wires and everything. This is the first node, that's V1, the voltage here. This is V2, and this is V3. I'll color them purple here so you get to see them. That's one node. This is another node, and this is a third node. V1, V2, and V3. And now again, you assign current going through the resistors. I don't care what direction you want to. You go this I4. I'll do this I10. I'll do this as I sub 1. I'll do this as I sub 7. I already use I sub 1, maybe I'll do this as I sub 2. So I assign them in any direction. Will make a difference. The only problem here, I have 3 nodes, right? V1, V2, V3. At the end, I'm going to have how many equations? 3 equations by 3 unknowns. Don't be surprised if you see 4 by 4 or 5 by 5. So it's nice to have a calculator that does simultaneous equations here, so you're not spending time on the math. I had one, but it died on me. So this is the 83, but I do have the 89, and I think it has simultaneous on it. I've never done it on it. I think it does. I used to have the 86, which is I love for simultaneous, but it died. So I got my 89 ready. Let's see if you can. So the first one, KCL at V1. Let's look at the current going into that node. What do you have going to that node? The way we drew the current, what's going to it? Absolutely nothing. Nothing going to that node. What's leaving that node? I see the 8. I see the 3. I see I1. And I see I4. Unless I'm blind, that's all I see there, leaving that node. Do you see anything else? So I can rewrite that. I1 plus I sub 4 equals what? Negative 11. KCL at node 2. What is the current going to node 2? 3. I sub 1 going to it. What's leaving that node? 7. And what? I sub 2. I sub 1. Minus I sub 2. Minus I sub 7. Equals what? Negative 3. And KCL at node number 3. The current going to that node, I see the 25 going to it. What else do you see going to it? I see I sub 7. Anything else? I sub 4.
I sub 10 is leaving.
I sub 10 is leaving. So the top one is going to it. Notice that I sub 4 is going to it. I sub 7 is going to it. 25 is going to it. I sub 10 is leaving. Clean that. We'll put them in order. I sub 4 plus I sub 7 minus I sub 10 equals what? Negative 25. How many equations by how many unknowns? 3 equations. Let's see how many unknowns. 1, 2, 3, 4, 5 unknowns. There's no way on earth we're going to solve for 3 equations with 5 unknowns. So we do KCL at each node. The next step is to look at these currents and write them in terms of the voltages. So while I'm looking at the picture here, let me look right next to it. Let me begin with the top, I sub 4. Notice I sub 4 is the current going this way. So it's this voltage minus that voltage divided by 4. What's this voltage? V1. What's this voltage? V3 divided by 4. Let's look at I sub 1. That's this current right here, going to the right. It's this voltage minus that voltage, V1 minus V2, divided by 1. I don't need to put the 1, but that's what that is.
I sub 2 now.
I sub 2. It's coming down. So it's V2 minus nothing, divided by 1. Bless you. I sub 7, I'll put it on the top. It's this current going that way. It's what? V2 minus V3 divided by 7. And I sub 10, which is what?
V3 minus 0 over 10.
V3 minus 0 over 10. Now, if you do these substitutions here, we will have how many equations by how many unknowns? 3 by 3, yes. So instead of I sub 1, I'm going to write V1 minus V2 over 1. I don't have to put over 1, but here we go, over 1. Plus I sub 4, which is what? V1 minus V3 over 4 equals negative 11. What's my LCD here? 4. So 4V1 minus 4V2 plus V1 minus V3 equals negative 44. Clean it. 5V1 minus 4V2 minus V3 equals negative 44. The next one is this one. I sub 1 minus I sub 2 minus I sub 7 equals negative 3. I sub 1, it's V1 minus V2 over 1 minus I sub 2, which is V2 over 1 minus I sub 7, V2 minus V3 over 7 equals negative 3. And what's my LCD here? 7? 7V1 minus 7V2 minus 7V2 minus V2 minus a minus, that'll make it plus V3. That's minus a minus. Equals 7 times 3, which is what? 21? Clean that. 7V1, 7 and 7, 14, 115. Plus V3 equals negative 21. And the last equation is this one. I sub 4 plus I sub 7. I sub 4, it's V1 minus V3 over 4. I sub 7, V2 minus V3 over 7 minus I sub 10, V3 over 10 equals negative 25. My LCD is what? 280? I mean, I could use calculators and divide them, but try and do some math there. 70. 280 by 4, 70. 70 V1 minus 70 V3. Divide by 7, that's 40. Plus 40 V2 minus 40 V3. And that's 28 V3 equals negative, big number. What's 280 times 25? 7,000? Clean that. 70 V1 plus 40 V2 minus, what is 70? 40, is that 110? 110 and 28, is that 138? Double check these numbers.
I thought it, oh, it's V3.
Yep. So that's my third equation. Now, how many equations by how many unknowns? 3. Now, here's my calculator. I'm not sure where the simultaneous. Anyone knows on the TI-83? Is in the catalog, maybe?
I can't see from that angle.
I don't know if there's simultaneous in the catalog or mode. Nope.
That's simultaneous
Where's simultaneous?
in the catalog.
In the catalog? I just got to go all the way down?
You can hit alpha and then.
Wait, let me clear this.
In the, go home.
Home. Is this home?
Yeah. Then you
Catalog.
catalog, then you can hit alpha
Alpha.
and then 3.
3 for S, is it?
Yep. Maybe what you can do again.
Alpha 3. Here we go. Begin with S, simultaneous. Oh, simultaneous. Now, how do we use this one? I don't know.
I'm not sure.
Do we just write the equations? Commas with them? Let's try that. I have no idea. 5. We use x, y, and z. 5x minus 4y minus z equals, where's the equal sign? Negative 44, comma.
I don't think you'd use a comma, I think. Never mind.
Because to write them all, I think.
You want to use the matrix.
You can do them matrix, but I think you can do them simultaneous. I like my old calculator. Where's comma? Let's try that. Where'd you go, comma? Comma, comma, comma. Anyone see where the comma is?
Right above the 7. Oh, never mind, that's on my.
Yeah. Above the semicolon. Oh yeah, I see it. Yep, thank you. I'm guessing. I have no idea if that's how it works there. I never did on this equation. 7x minus 15y plus z. If it doesn't work, we'll Google that later. Somebody can Google it. Equals negative 21, comma. The third equation. I can do them using any technique, but I'm trying to take the easy way out. 70x plus 40y minus 138z equals negative 7,000 and close parentheses. Now, if this is how it works, when I hit enter, it should accept them. Let's see. No. Doesn't like them that way.
What's the variable that you're solving for at the end?
I don't know. The question, do we have to put the variable where you're solving for?
So the way that you do it is you use the simultaneous and then square bracket.
Square bracket?
Yep, which is second and.
Yep, but they already gave us parentheses themselves.
Right, you still put the square bracket and then.
After the parentheses, you put square bracket?
Yep, and then instead of using.
Comma?
Instead of using X, Y, and Z, you would do like 5 comma and then minus 4 comma
Okay.
and minus 1
And you use semicolon after that?
and then a semicolon after that, yeah.
5. So you put a space after that? Must have been a space.
You wouldn't put a space, it's
Yeah.
just a comma.
Oh, 5 comma.
Yep.
5 comma. Negative 4 comma.
Negative 1,
Negative 1.
semicolon.
How about the answers? You don't put the answer? Oh, you.
Well, the answers will be at the end.
Okay. So semicolon after that. Let me delete the rest of them. How do you delete the rest? Let me just go right there, delete all that gibberish stuff. Come on. So if we put square bracket 5, comma, negative 4, comma, the first one, negative 1, comma, or semicolon. Semicolon, that says that's the end of the first set. I know we do that in programming.
Yeah.
In MATLAB, Mathematica, we do that. Then the next one is 7, comma, negative 15, comma, 1, semicolon. The last one, 70, comma, 40, comma, negative 138. Now I'm done with the last one. What do I do?
Square bracket close.
Square bracket to close. Okay, with square bracket again. There we go. Oh, second.
Then comma.
Then comma. I gotta put the square bracket again.
And then square bracket again, and then you put
The answers
answers separated by semicolons.
by semicolons.
Yep.
So negative 44, semicolon. Oh, I forgot the square bracket. Negative 44, semicolon, negative 21, semicolon, negative 7,000, close square bracket, close parentheses, I think. Let's see. Damn it, syntax error. Well, figure it out.
The answer from Google.
From Google, yep. Wait, let me just 1 second. I just want to know why this one, did I type something wrong here? I just want to check it out before. Oh, the first,
Between the answers and
yeah.
put 2 commas.
I put 2 commas?
Yeah.
And the first one is 5, actually, not 15. So it's 5, negative 4, negative 1, semicolon, 7, negative 15, 1, semicolon, 70, 40, comma, negative 138, close that. You're right, I put 2 commas here. Next one, negative 44, negative 21, negative 7,000, close that. Let's try it now. Am I supposed to hit shift after, or?
No, you can just hit enter.
And it worked for you?
Yep.
What'd you get for answers? So I probably typed something wrong.
12, 11.
Okay, so I guess I must have typed something wrong. So you get V1 equals what, 12?
Yep.
And V2 equals
11.
11. And V3 equals what?
60.
60?
Yep. 0.
So you really want to get used to your calculator because you're going to be using a lot of these. 3x3, 4x4, 5x5. So whatever method you know how to do it, go ahead and do them. Obviously, I didn't succeed here. I'll try it again without the video. I don't want to waste the video time on these. But that's how we solve. The next time we have to add something called supernode. We didn't discuss that, so I'll put that on the next video.